Recap of our turfgrass. Started recording. Today we're going to be doing a recap of our turfgrass field day that we held yesterday in Dallas. And so today on our call we have Dr. Mung Mung Gu, who completely ghosted us at the field day. Bought her a shirt and everything, and she didn't even show up. So I sent it back with Chase, by the way. But in a weird turn of events, Mung Mung didn't come, but she was the only one that had a poster at the event, which is great. And so the rest of the crew, Laura Miller, she was at the field day yesterday, and you'll hear a little bit from her stop today. And then Dr. Becky Bowling was also present, and you'll also hear some from her stop and myself as well. So let's get going. You can see from our first slide that we had good participation at the field day. We ended up with having about 165 people registered at the end of the day, and a few scragglers here and there too. So we had a really good turnout, and we had a great day of weather. We sold some great merchandise and talked about a lot of turfgrass for sure. All right. So first thing we wanted to do is just give you a little view of the schedule that we had. We had 4 hours of education throughout the day. And so it was kind of set up where each talk was 25 minutes, but it rotated through twice. And so we had a pretty wide net of education going on, from, hardcore breeding work to irrigation audits to impacts of cultural practices on root health and infiltration, new A&M cultivar updates we'll talk about today, St. Augustine's, zoysia grass, pests, weeds, diseases, all kinds of things were represented at our program. We were also able to offer some CEUs as well as some education credits through the golf course superintendents. So just going to show y'all a map of how it's kind of laid out. The Dallas Center has changed a lot since a lot of folks have been here. And so a lot of folks, were coming for the first time in 2 years. They were able to see our brand new buildings and new facilities and things like that. But the biggest thing that they got to see was our almost 11 to 12 acres of turfgrass research. And so we had a pretty big field to cover. And so we were able to offer 16 total stops, but attendees, of course, unfortunately had to choose only half of those to be able to go to, because we just didn't have enough time for all the stops to be visited. But good thing is we always had some participants at each stop, so that really worked out well. And I'm glad that we were able to have a divided group, and everybody had some attendees. And so just a few snapshots from the day. We won't get to talk about all the stops. We're really only going to cover 3 or 4 of the stops that we had. But, we had a welcome. You can kind of see how the room was set up, attendees, obviously very attentive to what I was saying. And so we were really thankful for everybody that came out, and also for all of our sponsors that represented us as well. We also, the middle photos representing some evaluation of some of our zoysia grass elite lines under ET deficit conditions with Dr. Megan Meeks did that. So pretty much we take into account how those grasses are doing throughout the year in drought conditions, and we water them only as needed under deficit conditions to see how they'll work. Another stop that we won't really talk about today, but some of our elite St. Augustine grass lines have been going through some herbicide tolerance work, because as some of you may know on the call, St. Augustine can be kind of sensitive to some of our herbicides. And so we don't have a lot of options when it comes to some of our weeds, especially crabgrass, especially post-emergent. And so we're working with some chemical companies to take those kind of things into account, new chemistries coming through, new modes of action, those types of things. And we're trying to test those on some of our new lines. Another thing that's very important when we start talking about an experimental grass going commercialized, the most important thing from a sod farmer's point of view is that it's got to be able to be harvested from that sod farm, right? We've got to be able to block it. We've got to be able to put it on a pallet, pick it up, and transport that to the end user. So we have a device that you can see in this photo on the table. Hopefully you can see my pointer. That is a sod tensile strength device. And so basically what that allows us to do is we can go out, cut a piece of sod, and we can put it in this, what we like to call a torture device. There's some nails here that are sticking out, and it goes down into that sod. We use a force system where we can measure the force of the peak force of where that sod breaks into in the middle. And so it gives us a great idea how strong that sod is. And we can compare those experimental lines with already available, commercially available St. Augustines like Raleigh or Floratham, and say, these are just as good as those or better. So we should have no issue getting them out of the sod farm for production purposes. Let's see what else we got. We had, so there's, as you know, and have probably heard many times on this webinar, the National Turfgrass Evaluation Program is a big program that goes through the United States. Multiple different states represented, multiple different universities have the same exact trial at their locations. And so in this case, we were talking about the zoysia grass, the zoysia grass NTEP trial. And so these grasses go under, 4 to 5 years of screening in different locations. So we can test them and see how they're doing in Dallas, how they're doing in Florida, how they're doing in California. So we had Dr. Ambika Chandra talking about some of those lines here in this left photo. Another great stop that we had was Charles Swanson. He was showing some new irrigation technology, as well as how to conduct an irrigation audit effectively. And so he had some irrigation cups set out, and he told and taught all the attendees how to figure out what your irrigation system's putting out. Why is that important? We talk all the time about fertilizing. We talk about putting pesticides down, putting insecticides down. What do we have to do when we put those products down? We typically always have to water those products in, or we have to put a certain amount of water on those areas that we treat. And so it's vital for us to know how long we need to turn our irrigation system on to be able to have those products work effectively. And so that's how we can, be the most successful, the most effective with those products, is follow the label, but also doing those watering practices appropriately, really going to help us out. Let's see, Dr. Youngkey Joe, he's our pathologist at Texas A&M. I think he had one of the largest groups at his stop at the beginning. So his was the first stop, and I looked over there and I was like, dang, there's like 80 people over there at his stop. And so he was talking about some disease management. He went through the common diseases, but we were starting to experience on some of our zoysia grasses what looked like some take-all root rot starting to occur. We had it coming out in spring, and we sent a disease sample in that came back with take-all root rot and a little bipolaris leaf spot. And so, as most of y'all know on here, zoysia grass is susceptible to those things, but this was an interesting year. We don't typically see those as much on zoysia grass as we do some of the other varieties or other species. So it was great to have that disease kind of starting out at his talk, so he could talk to the attendees about recognizing the initial symptoms of those diseases. So that was a great stop for sure. Okay, so we were very fortunate to have our colleagues down from College Station bring up a GPS sprayer. They had taken a Toro sprayer and retrofitted it with a GPS unit. And so, there's some pros and some cons to GPS sprayers. One of the cons just being the overall initial cost. It's very expensive to buy the unit. It's also very expensive to retrofit the unit. But what's great about a GPS sprayer is once you log those coordinates of the area you want to spray, it's going to only turn the nozzles on when you go over that area that you have logged in the sprayer. So it saves you a lot of time, saves you a lot of money from not over applying, not doing double applications here or skipping an area here. And so I'm going to try my best to show you in a video kind of when the nozzles turn on and when they turn off. And so the point of this stop was to do an A&M block logo, as you see over here in this left photo. So in the video, hopefully you'll see the middle nozzles turn on when they're doing the bottom of the T. And then once they get kind of to the bottom of the A and the M, you'll notice the side nozzles turning on. And so really cool to see. There's some stuff going on in the chat. I want to make sure.
We're good.
Oh, okay, good.
Yeah.
Y'all hear me okay? Let's see if the video will work. So nothing's turned on. There goes the middle nozzles. See those turn on. Nothing on the side yet. Sides have just turned on. So it's kind of tough to see. In that video, but this is a really great technology that can really save you money in the end. Of course, it is a first initial investment, of course, but Dr. Straw and his research assistant, Weston Floyd, are in the process of trying to use the GPS sprayer on different sites to figure out how much money they can save and when you would expect to see that return on investment from that sprayer. And so it's really, really cool. It saves you from spraying areas that you don't intend to spray. And so you cut down that the accidents and the oversprays and all the money that you may spend on pesticides.
So Chrissy, how hard is it to map out your areas with that?
So it's really easy. All I had to do was send Dr. Straw a Google Earth image of the area, and I just had to make a rectangle, and he was able just to go in and program that into the sprayer, and it just does it automatically. So it's really just a little bit of legwork on your end. You know, if you're on a golf course or a sports field, you're going to have to go out and map your area. And as long as you know the GPS coordinates, you can pretty much just do it on Google Earth, and you pretty much just need to upload it on a small chip, and you insert it into the GPS unit, and it does it automatically. So as long as you have the ability, you know, to have some type of internet connection when you're uploading that, you don't need one while you're spraying. So everything is preset. So it's pretty simple once you get used to actually doing that. So
that's very cool.
Yeah, very cool. And I think they ended up spraying that area 5 total times to kind of make the colorant darker. And Weston said every time they sprayed it, they used exactly the same amount of product every time. So very accurate.
Very accurate.
Yes. All right, Becky.
Okay, so I was fortunate to be able to get out there yesterday with our new program specialist, Dean Manchillo. And so Dean and I are both part of our new growing urban water program here at the center. And one of the things that we're looking at is trying to do some very applied research looking at what are appropriate cultivation and top dressing practices for those established turf grass systems where we are having issues with compaction or just issues in general with our really heavy clay soils. One thing that we really want to try to encourage, especially in urban landscapes where we have a lot of disruption of the native soil, is we really want to try to encourage deep roots and optimal infiltration for water capture. So we want water to be able to move deeply into those soils. This not only helps us be more efficient with the water that we get, whether we're irrigating or we're talking about rainfall, we're reducing the runoff of that water, the movement of that water off of our property. And as part of this too, what we end up seeing is a reduction in pollution. So one thing that we deal with a lot when we're talking about water is non-point source pollution. So this idea that when we talk about our watersheds, we talk about our favorite lakes and streams, that especially when we're in a lot of these big urban systems, we see that runoff leaving landscapes and leaving those crossing across those impervious surfaces will pick up nutrient pollutants, pesticides, bacteria, and it will carry those things into our surface and groundwater resources. And it can become a really big problem. And so one thing we really want to encourage is that water move into our soil and stay on our landscape. And Many of the plants that we bring into the landscape, including turfgrass, actually have the ability to help filter clean water. And so we call this phytoremediation. That's our buzzword that we use to describe this. And so again, this all ties back to soils that can promote deep rooting and encourage those benefits. And as many of you know, that here in Texas, we often may run into the challenge of having those really heavy clay soils. The other challenge that we may see sometimes if you're joining from Central Texas is we may have very shallow, blocky clay soils or rocky soils or soils that are high in caliche. So a lot of diversity in our soils here, a lot of challenges for each soil type. So what we wanted to look at was when we're talking about cultivation, meaning aerification, what's really going to be beneficial with our clay soils? You know, a lot of the research that's out there is not for Texas. It's not for the soils that we have here. Most of that research comes from other parts of the country. And so we really wanted to look more closely at what makes sense for where we live. And then similarly, a lot of conflicting or confusing information out there about top dressing materials. You know, sand historically has kind of been the default recommendation, and it may be the right recommendation in a lot of scenarios, but again, not a lot of good data as to whether or not it's appropriate for our soils. And similarly, we get questions a lot about compost materials. We know that a really good high quality compost material can be very beneficial when we introduce it into our native soils. So we'll go for it. Chris, I'll have you advance real quick. So again, one of the first things that we wanted to look at was this question of cultivation. We set up a demo for field day to talk about this. We actually have two research locations. One is here at the Dallas Center, is a little bit more of a walk than we wanted to make people do yesterday. So we set up a smaller demo closer to where all the other research plots were. And then the other location is actually in the city of Louisville. It's at Railroad Park. So these are pictures from that location. We wanted a location that represented more of that large scale municipal park scenario. Sites that get a lot of traffic, sites that may have some different challenges when it comes to management. And then we also wanted a site that represented more of a home lawn. So our site here at the Dallas Center really does more of that. So as you can see here from the Louisville site, this is not a piece of equipment that we would take out onto most home lawns unless you just happen to have a lot of acreage. But for the average person, we're going to be looking more at a walk behind aerator. But we wanted to, one of the questions we wanted to answer was, you know, do we really see any benefit from a solid tine aeration on our soils, meaning that we're just puncturing holes into the soil, we're not removing any material, or as we've kind of suspected, do we really only get a lot of benefit from removing material from our soil? You know, I think one of the theories is that sometimes when we're doing that solid tine in our clay soils, we're really just moving the compaction around. We're not necessarily addressing it. And so this was one question that we wanted to answer. So we did do multiple cultivation practices at both locations. Like I said, for our lawn type scenario here at the center, we did not use this equipment. We actually rented a standard walk behind aerifier that an average person could get at the store. So little different approach at each site. Next slide. And then again, in terms of top dressing materials, you know, we've got our sand as our standard that we're looking at as part of this study. So in some plots, we did our cultivation first and then top dressed with these materials. In other plots, we did no cultivation as a control treatment. In addition to the sand, we had a high quality compost material that was donated very graciously by Soil Building Systems for us to look at. Then we looked at an expanded shale product. So this is a product that's been discussed quite a bit as an incorporated product for site preparation. It's supposed to help improve infiltration in our clay soils. But what do we do? Is there a way for us to bring that in once the turf is there? And so that was a question we wanted to ask, was if we combined this with cultivation, is there a way for us to get that into the soil profile and see some benefit there? So we used a finer graded product that was provided by a company called Arcosa, and they also provided some support for this research as well. And then our final treatment was actually to look at the compost and the expanded shale together. So we've collected data on things like turfgrass quality and appearance. We've collected some NDVI data to look at green color. We've looked at density of the turf, and then we're collecting penetrometer readings or penetration resistance to try to look at the impact on soil compaction. So how much force does it take to move a probe into these plots once we've done these cultivation practices, once we've top dressed with some of these amendments? And that should give us a sense of, are we getting a benefit from doing these practices, and what is that benefit? And and so hopefully that'll help us answer some questions. And even if the answer is no, none of this does anything helpful, that's still good for us to know, because we don't want to put time and labor and effort into things that aren't going to be beneficial and serve us, especially if we're talking about managing a large facility or multiple sites. And it'll also maybe help provide some insight as to, well, what new things should we look into doing that will be beneficial?
Okay. My computer is on the fritz, so I don't know, slides are advancing with me not touching anything and all kinds of stuff. So hopefully that'll be all right. Okay, so the next part we're going to talk about is a stop that I did. So it's kind of a Texas A&M Turfgrass Cultivar update and breeding program update. And so what you're seeing through these photos are mostly zoysia grass. But we also have a zoysia grass and a St. Augustine breeding program here at the Dallas Center. In terms of St. Augustine, the plots that I showed you earlier with the herbicide tolerance and the sod tensile strength machine, those are some of our St. Augustine elite lines. And so we kind of have 4 that we are looking at very closely to be commercialized in the next 2 to 3 years. And so I'll talk a little bit about some differences between those. So let's talk about some common cultivars that you already know of on the market. So number 1 would be Raleigh St. Augustine. We have that as a comparison out in the field. And so we'll talk a little bit about the difference of genetics. And so Raleigh is a diploid St. Augustine. And so when I talk about diploids, we're talking about plants that are going to be more, usually more aggressive, fill in quicker, maybe establish quicker, but they might not have some of those traits that we're looking for as improved as we're looking for in terms of drought tolerance, shade tolerance, cold tolerance, as well as stresses that are coupled. So combination stresses might not do the best under shade because it might have some disease susceptibility. So, even though it might be a very shade tolerant grass, if it's susceptible to disease more, it's going to have a hard time under those shady conditions. Now, some of the newer genetics that we're looking at are called polyploids. And so when we talk about those plants, an example would be like Floratam. Floratam is a polyploid plant. And so what we're looking to do in our turfgrass breeding program is not release something that's a little bit better than Raleigh or a little bit better than Floratam. We're looking for something that's going to be substantially better. Okay. Why would we look at releasing a plant very similar to Raleigh when Raleigh is very popular already on the market? So we're looking for something that next step up. Okay. So the ones that we're currently looking at have vast improvement over our commercially available cultivars that are already out there. So one in particular, 1318, that's the experimental number. 1318 is going to be very similar to Raleigh in that it's a diploid plant. And so it's going to, establish a little quicker. It may recover a little quicker from some stresses, but it's still going to be susceptible, similar to Raleigh in terms of disease. So things like gray leaf spot is going to be very similar to Raleigh. On the flip side, we have 1618 that is going to have polyploid genetics. And so it's going to be a bigger plant. The leaves may be a little wider. The internode lengths between the nodes may be a little longer. The stolons, you may see be a little bit thicker than the typical Raleigh that you're used to seeing. But with those genetics, we see an increase of tolerance to things like drought, in decreased water requirement. And so in terms of things like shade tolerance, 1318, 1618, Raleigh, if everything else was equal, if there were no other stresses that we were thinking about, no disease, no drought, no heat, then they're going to be pretty equal on the shade tolerance line. But when we bring in things like disease and shade, drought and shade, cold and shade, we're going to see the plants like 1618 going to excel. They're going to be performing better under those conditions. That's what we have found so far in our research trials and in other locations. And so we're at the end of trying to decide, which one to go with and making all those agreements and everything. And so we're hopeful that in the next 2 years, we will have a St. Augustine to offer the consumer market. So that means that you would be able to go purchase that grass in the next 2 years, because, once we decide that a grass is going commercial, we have to go through expansion. And so the sod farmers that are going to grow it have to expand that material. And typically that takes a year to 2 years to get all of that together. And so, some of these crosses that I'm talking about, some of the experimental lines that I'm talking about were made 10, 12 years ago. And so these grasses have gone under intense screening, not only at the Dallas Center, not only in College Station, not only in the greenhouse, but, all over the US. And so these grasses are thoroughly vetted before we put them out. So we know a lot of things about them. One that we're looking at pretty closely, 1618, which is the polyploid. Currently, we found through our research trials that it requires 60 to 80% less water than any commercial available St. Augustine grass right now. And so we currently have the 1318 and 1618 out on some demo sites around the DFW area. And we've got reports that they've had to water 1618 much less than the 1318. And so we are seeing those genetics come into play. But the thing with the polyploid genetics is we're not used to managing that. And so that's going to be another hurdle, right? We see these improved characteristics, but now we have to take charge and do that appropriate outreach education, teaching folks how to really manage that. And that's all the way up from the bottom, sod farmers to the end user. And so if we have these great characteristics, and we need to change our management scheme to actually see those come through. So one more thing I wanted to mention about the breeding program before I pass it off is we, in the St. Augustine breeding program, we employ a technology called embryo rescue technology. And so if you didn't know it, St. Augustine is a fertile plant. That means it produces viable seed. But as you know, we don't have any seed available on the St. Augustine market. And that's because see, did it again. There we go. That's because whenever the embryo is developed, there's something called an endosperm that feeds that development. And so basically in St. Augustine, the endosperm is very, very tiny. And so it runs out. It basically runs out of fuel, runs out of food to feed that development of that plant. So here at Texas A&M, we are the only breeding program that currently uses this technology. It's not proprietary. Anybody could do it. So it's out there. Everybody knows, about it, but we are just the only ones currently using it. So basically what we do is we rescue that embryo. And so one of our breeders here, Dr. Genovese, he can go collect the pollen, and he can pollinate himself with a little tiny paintbrush. He just goes and brushes that on there and actually creates a plant that way. Or he could go in and rescue an embryo before it runs out and continue feeding that on some kind of medium, like a sucrose medium, some type of sugar medium to feed that plant. And so through that technology, we've been able to create thousands of hybrids that would have never seen the light of day. And so that gives us a big advantage. And so 1618, the grass I was just talking about with the less water requirement, was developed through embryo rescue technology. And so if we weren't doing that kind of stuff, then we wouldn't have missed out on tons of good genetics. And so it's kind of exciting. I'm getting chills talking about it. Isn't that crazy? It's true turfgrass nerd. But it's amazing. It's amazing technology. And even further, typically when breeding programs make crosses, they have to put them in the greenhouse, screen how that looks when it's phenotypically grown. So the genetics might look great, but how's it going to look when it starts actually growing? And so we have the fortune to have a molecular geneticist here that's on our turfgrass team. Her name is Dr. Qingyi Yu. And so what we're able to do is we're able to develop markers for the certain traits that we're looking for. So we might be looking for a drought tolerance trait or a shade tolerance trait or a cold tolerance trait. And we can take those thousands of new hybrids that we just created and we can map it. We can look at, oh, this hybrid doesn't have that trait we're looking for, throw it out. This one doesn't have that, throw it out. And so that saves us years of work, that we don't have to put those grasses out in the field and somebody go look at them for 3 years. We can go ahead and cut out 50% of those hybrids in the lab, and they never go out there because they wouldn't be worth pursuing. And so it's amazing how far the technology has come in the breeding program. That's just a little snippet. And honestly, I don't know as much about the breeding program as Dr. Chandra, of course, but that's just what I know. And it's amazing. It's amazing technology that we're working with here, and really working for the lives of all the Texans. And we want to make sure these grasses are going to be something that you can use on your home lawn, to a golf course, to a sports field. And so we're working really hard on that. Okay, I'll pass it over.
Really, really cool how much faster breeding can be these
it's
days.
amazing.
Not just in turfgrass, but those that marker technology is used in all kinds of plant breeding.
Yes, and like Laura's saying, that's not just the turfgrass folks using that, but that's just an ability that we are lucky to have here with our geneticists just here, and able to do that kind of stuff. But yes, it's becoming more and more common, kind of the common thing to do now. And so that cuts out those 20 years that it used to take, might only take, half the time now. And so that's really great.
Yeah.
All right. So I think Laura, you might be next. Oh no, I'm next.
No,
And
you're next.
I'll do this one and then we'll pass it over to Laura. So another one of the cool stops we had was called Tools of the Trade. And so we actually had Dr. Chandra, which is right here. This is Dr. Chandra. Then we had myself, and then we had Dr. Qingyi Yu, who's right here in the little hat, if you can see her. And then one of our research technicians, Justin Eads. And so pretty much we just wanted to talk about, here's some different tools that we use to either collect data, detect stress, and Dr. Yu talked about her molecular technology, as well as another grant that we have through TDA, which I'll talk about in a minute. But the coolest thing that we talked about was Dr. Chandra has invested into drone technology for our program. And so, there's only so much that our naked eye can see, right? There's only so much we can see. With this technology and the sensor technology that we have, we can detect things that we would never be able to detect with our naked eye, and say, hey, these maps are showing a stress map almost, and it's detecting the stress before we would be able to see it, and we can go out and prevent that stress from occurring now because we see the changes over time. It's really amazing. It takes we have 11 to 12 acres of turfgrass here. It takes probably 20 minutes for her to fly that drone over the whole property. But then, of course, there's some legwork on the back, right? We have to process those images. We have to map out the actual plots and all of that. But it's just amazing technology that is becoming more and more common in the turfgrass industry. Golf courses are starting to use sensor-based technology. Heat maps are being created. You can see moisture issues. You can see stress issues. You can see all types of things with that drone technology. Super, super cool. Some of the other tools that we talked about are our typical moisture management tools, like the TDR probes, the POGO probes that detect volumetric water content, helps, keep a consistent moisture level, also can be used to help detect problems with the irrigation system, those types of things, dry spots, those types of things. Hardness tools that measure hardness of athletic fields, hardness tools that measure hardness of golf greens, and kind of give you a great idea of, I really like that my golf greens playing this way. Okay, let's try to keep these consistent measurements going with the moisture levels, the hardness levels. It's getting too soft, I need to roll. It's too fast, I need to cut back on some of my maintenance protocol. Really cool things that we can do now with these tools, and it takes the subjective measurements out. If I go out and Laura goes out, we might see two totally different things. With these tools, it keeps everything streamlined, and then we can take our data and compare it to data at NC State or down in College Station, so it gives us a big capability to do a lot of consistent measurements for sure. One more thing I want to mention, and I might have mentioned this before in Chat with Green Aggies, I cannot remember, is that we currently have a grant through the Texas Department of Agriculture to develop DNA markers for all of our commercially available St. Augustine and zoysia grass. So pretty much that means we have taken Raleigh, we have taken Floritam, we've taken Xeon, we've taken Innovation, all those fun things, and we've mapped the genetic map of those grasses. And so pretty much that gives us the ability to test other grasses against those and figure out what cultivar they are. So if a golf course calls us and says, hey, I wanted to get Xeon zoysia grass for my tee boxes, and it's looking like something different, I'm not sure, or maybe I got a contamination or something started popping up that didn't look like Xeon. We have the ability to take that contamination, we just need a small amount of grass, about as big as this circle of my finger, on what, really small, really tiny, just leaves, and we can run it through our machine, and then it will show us the map of that grass, and we can compare it to our other genetic markers that we have. And so it's really cool technology that we're fine tuning to get to the point of really telling each cultivar between each other. And so we've already been able to use that tool to do some of those contamination things. Right now we are offering that as a free service, because we still have the ability to use the grant money for that. And in comparison, if you were to send a sample to somewhere like the USDA ARS system to do this, it would cost you well over $1,000. So right now, take advantage of that. We are able to do that for free. And so we need these samples for our grant. We need to show that, we have developed this technology and honed it in. And so we can't do that without samples. And so if you are interested, please contact me, and I'll be your contact person for that. You can mail me a sample and we can tell you what it is, or at least get an general idea of what it is right now. We're still kind of working on that technology to get it really precise. So that is something that we are offering at the Dallas Center. Okay. Oh, what happened to your slide, Laura? No.
Oh my goodness. Well, what time is it, y'all? Well, it's okay.
No, I'm going to find it.
Okay. Well, I basically have really enjoyed this presentation because I didn't get to go around and see everything. There it is. All right. Because I was doing this. So I was back in the far corner of the center in a weedy field, and
purposely weedy.
Especially weedy field. But it was great because we got to talk about a lot of cool things with integrated weed management. We started out with a little weed ID, event. We had a set of weeds to identify, and they were marked with little stakes. You can see somebody bending over looking down at a weed, but they were getting
Raymond.
Yeah. Is that Raymond?
I think so.
It could be. Anyway, So we started out with that, but the main reason that I wanted to do that was not just so that I didn't have to talk the whole time, but also because the first thing you need to do in any kind of integrated pest management is what, y'all? Chrissy's gonna have to
Proper
say.
ID.
Proper ID of your problem, right? Every single time, that's the first thing you have to do. So that was fun to get to do that. And these are some of the weeds that we had out there. It was, as I said, a very weedy field. We also got to talk a lot about how, and Dr. Bowling has a great presentation on this, about how weeds can kind of tell you what's going on. And when you see things like King Ranch blue stem, which is, you know, right there, those seed heads waving near the table, when you see things like King Ranch blue stem and you see sandburrs and you see spurge, prostrate spurge, you know that you're dealing with a site that's pretty dry, that probably doesn't have a lot of fertility, that probably isn't mowed super frequently. And so you know that there are cultural practices that you could implement to try to manage those weeds, you know, that you could use that kind of approach to try to get rid of some of those. We also talked about, that's Slender Aster in the picture there, but one of the other related weeds that we have, and you can see those kind of brown clumps next to the King Ranch blue stem, was we had a whole lot of an annual fleabane, a daisy fleabane. And so it's on its way out, it's fixing to die. So we talked about how the fact that there's a big difference between, you need to know the life cycle of your weeds, because something like Dallas grass up there in the corner is going to be a perennial weed that's going to come back. It's going to live through the winter. It's going to constantly be with you, but something like that annual fleabane is fixing to be gone. So you don't really need to do anything to it right now. You need to make notes. And if you're fancy and have a GPS sprayer, I guess you could make notes of where you wanted to put out some pre-emergent for that one in the spring sometime, you know, or if you're clever like that. But even if you're not that high tech, you can still make notes and say, you know what, I really had a problem with this in this area last year. So I know that I need to go after those spring annual broadleaf weeds next year with my pre-emergent. So that's one really cool thing.
Yeah, for sure. You know, I'm still getting emails about, this is the time of year you get emails about the summer annual weeds, right?
Yes.
Because that's when you notice the flowers. That's when you see them start, you know, producing seed heads. And that's when, just like Laura said, perfect time to go scout for your issues now, and you know what your issues are next year. This is not the time to be spraying anything with a herbicide for the annual and the seed heads and everything so mature. It's just, but this is when they see it all, right?
Yeah, this is when it's not bothering you. This is when it's bothering you. Yeah, you're walking on that Slender Aster, that picture in the middle, and you're walking on those woody stems, and your feet hurt, and you're noticing all those flowers, and you're like, this is not my turf grass. What is this? You know, this is not what I want. But Slender Aster is a really great example. Everybody notices it in the fall because it's flowering, but you cannot control it well right now. You have to control it in the spring. Yeah, you have to control it in the spring. But right now is when you're going to notice it, because it's telling you it's there. This is also a great example of the fabulous adaptivity of weeds, because they can, that plant would be 3 feet tall if no one ever mowed that area, but it's able to grow down low underneath the mower like that, because it's you know, able to adapt to its situation. And you'll find that a lot of weeds are plants like that are very opportunistic, that they can take advantage of a hole in the a literal hole, you know, where there's nothing growing. They can take advantage of that, and they can find a way to stay alive in that situation. So they're pretty cool. Some of the fun things you have when you're looking at weeds is talking about, people will tell you things about different weeds. And down there you see the spurge, the prostrate spurge. One of the guys said that someone told him, and he said he's very sensitive to poison ivy, but that if you're get exposed to poison ivy and you start seeing a little bit of a rash, if you'll find some spurge, and you know, it has that milky sap, which I can believe this might work. He said, if you'll rub that on your poison ivy spot, it'll calm it down, and it'll, you know, not spread like it would. And I was like, well, that's probably not bad advice. You wouldn't hurt yourself anyway. So if you want to try that, I'm going to try it sometime when I'm
out. I was going to say, well, I'll let you try that.
I'll try it. I'm going to try it. I'm sensitive to poison ivy and I get into it all the time. And, the best thing to do truthfully is go take a shower. But if you can't do that, sometimes you can't do that. So, you need to treat yourself in the field. You can use the ethnobotany there for you. Anyway, we had a lot of fun out there. This is a good time of year to look at your weeds, to map out the problems that you need to tackle next spring. It's also, of course, the time of year when we do put out pre-emergent herbicides for those winter weeds that we're not really seeing yet because it hasn't gotten cool enough for all of those to start germinating. But this is the time of year when you can manage those winter annuals with pre-emergence. So
yeah, I think I looked at the soil temperatures and they're hovering around 80 right now in the Dallas area. Now down south, it'll be a little warmer probably. But if you recall on our preventative, I can't remember that, maybe 2 weeks ago or 3 weeks ago, we talked about how we had changed our large patch recommendations for St. Augustine to 80 degrees in the soil at 2 inches. And for 4 to 5 days. So if you're in the Dallas area and you've had chronic large patch in the past, this is the time to start thinking about those St. Augustine applications. Still have a little bit of time for the zoysia because we're recommending 70 for that. But like Laura said, not a bad time to start thinking about pre-emergent apps too, because our recommendation is usually 70 to 72 in the soil for those. And so not a bad time to think about it.
So it was great. So we got to talk about a lot of cool things.
Great. I was going to mention something else. As you can see from this photo, these photos are off Aggie Turf, but the photo with all the attendees standing there, this area is completely unmanaged other than mowing. And so we do have some buffalo grass randomly throughout there, and we do have some Bermuda grass randomly throughout there, but the primary stuff is weeds, right? And so this kind of have developed over time. When I first got here a couple years ago, we hardly had any sandbur on the property. Laura, there was a ton of sandbur out there, wasn't there? Mm-hmm. So it has moved very quickly. And even at the end of the day, I found 2 on my shoe and I wasn't even over in that area. And so that's how weeds spread, right? Like unknowingly, I could have taken that and who knows where it would have went, and it would maybe germinated a year from now or maybe 2 years from now, who knows. And so that's how easy it is. And these attendees probably spread stuff all over the place. So
yeah, you probably got weeds all over the center now. Yeah,
we're definitely going to be putting pre-emergent out. But the point is, I mean, it doesn't take years and years for these to spread. It can happen in the season where the population just keeps getting bigger and bigger just because of movement from people or equipment or whatever it is. So just a reminder
that really important part of integrated weed management too, is that kind of prevention and sanitation and try not to.
And so here's our last slide, and until next time, this is our Dallas Turfgrass team here, and this is us at the end of the day. Dr. Chandra looks actually dead, so it was a long day, but we had a great time, and we just want to thank all of our sponsors. We had about 7 sponsors at the event, and we really appreciate the donations that we receive to take care of some of our areas. And I think that's it. We want to remind y'all, of course, that we still have seminars the first and third Thursday of the month. And so in 2 weeks, I think we're doing a group effort. Let's see. Yep, here we go. In 2 weeks, we're doing fall favorites, some of our fall favorite plants and management tips, and that will be all of the Chat with Green Aggies group members. And so we're looking forward to that. But we do want your feedback, of course. And so if you're on today and can take a few minutes to complete our survey, then we would definitely appreciate that. And then just as a reminder, we're always on YouTube. If you want to share any of our videos with your friends that maybe couldn't come, or rewatch them, before you go to bed or something like that, that'd be great. So, and
we did have a little conversation in the chat. Turf Field Days every year, should be next October in College Station. So plan ahead and plan to attend. It's a great event.
Yeah, so we're going to start trying to hold our field day. So like next year, we'll hold our field day in College Station, and we'll hold our Turfgrass short course in Dallas, and we'll hope to rotate that every year.
Right.
And so, you know, if you're interested in that, and you maybe are always in the Dallas area, you can never make it to the College Station area for the 4-day course, maybe this year you can do that in Dallas. So typically we have our Turfgrass short course the first week of March, and typically we have our field day the first Wednesday in October. So that's typically the ones that we look at. All righty.